This is Ship It with Justin Garrison and Autumn Nash, a podcast about everything that happens after Git Push. Ship It is brought to you by Fly.io, the home of Changelog.com. Launch your apps close to your users all around the world. Learn how at Fly.io.
Hello and welcome to the Ship It Show. I am your host, Justin Garrison, and with me is Autumn Nash.
Hi, guys.
Thank you so much for subscribing. This is the first episode back after Gearhard was running the show, and he did a great job for 90 episodes. And last year, when the show went on a hiatus, I was a subscriber, and I was very sad to see it go. And so I emailed the Changelog folks, and I said, hey, is there any chance that I could help out with the show? Because I love talking about software and everything that happens to software after you get committed, basically. Whenever software turns into, or code turns into software, is the thing that I'm really interested in, and running systems is a big part of my career and all of my interests. So they thankfully said, let's talk about it. And here we are. So Autumn, thank you so much for joining me.
Yeah, I'm really excited to be here and to be on the podcast with you.
We usually will start the show with hopefully a couple links or things that we found interesting for the week. But for today, because this is episode 91, the first one that you're hearing our voices, we just wanted to give you a little background on us because we probably don't know you and you don't know us. So wanted to just go over a little bit and before we jump into our interviews. So like I said, I am Justin. I have been an infrastructure engineer and developer and sysadmin for quite a while now. I started my career in the help desk at a university, worked up to sysadmin role, did in like VDI environments. I worked at Disney for 6 years, working on animated feature films and Disney Plus, and worked on Amazon on EKS for quite a few years. So now I'm at a company called Sidero, and I just enjoy the infrastructure space. Oh, I also authored Cloud Native Infrastructure a few years back with a good friend. And so I've been doing this for a little while. I'm very much involved in open source communities and enjoy talking to people that are working in their industries on running software, SREs, DevOps, platform engineers. All those job titles are just people I love meeting at conferences and seeing what they're doing. Autumn, how about you?
I'm Autumn Nash. I am a software engineer. I've worked in big tech for about 4 years. Before being a software engineer, I was a solutions architect, a specialist database solutions architect, and I did NoSQL. And before that, for years, I taught coding with MilSpouse coders. So it's a nonprofit organization that empowers military spouses with code and teaches women how to get into tech. I'm on the hackathon committee, and I'm now for the last couple of years been the education board chair. So I teach coding. I like to speak about coding and give talks, and I think that's all.
That's all. That's still quite a bit.
It's like, oh, and I do lots of mentoring with rewriting the code, MilSpouse coders, and a few other people.
And when we were talking about bringing this show back, Autumn, one of the main reasons I wanted to have you as my co-host for the show was because your background and interests are so much different than mine. And I love having someone that can argue their points and have valid points and push back on anything that I'm like, oh, well, just do this. It's like, I know very little about databases, and I know very little about NoSQL databases. I've used them for various things, but I am no expert. And having you on the show, I think is going to just allow us to not only talk to more people more in depth about some of the topics, but also just give a variety of backgrounds and how things you've worked on and companies you've worked with and programs you built are just very different than the things I've done.
Do you use a lot of Java in system engineering?
I have never written a single line of Java in my life.
Oh, Java's my jam.
That is exactly another reason that I'm excited for this, because that's just something I wrote some Scala for some example code, which is like the closest I got. And I actually did some Kotlin for a little bit, but I don't jump into the JVM very often. I have fine-tuned the JVM and run Tomcat apps from back in the day, but it's not something that I've written myself. I tend to stay in the like systems, Python and Go area.
That's exciting because I feel like I'm definitely down to learn a ton more systems from you. I do love Python though, so we can totally agree on that.
And for this show format, we like to bring just some interest, some things that we've been learning or doing over the past week. This will be a weekly show again, but we also want to bring in guests from various industries and technologies and systems to talk about what it's like to run software at different scales, small and big, in clouds and on-prem, in a variety of different use cases. And so today's show, we have Jason Hall, who is from Chainguard, and Chainguard is a security company, but they also build a lot of container images. And I've known Jason from the container and Kubernetes space. And when he reached out about building containers, I wanted to dive a lot deeper into that. So we can jump into the interview with Jason, and we will see you afterwards for a few extra things to close out the show.
What's up, friends? I'm here in the breaks with Salma Alam Naylor from Sentry, Senior Developer Advocate. Salma, I want to talk to you about root cause. I know that getting to the root cause of an issue, even here at Changelog, can be quite challenging, but then we use Sentry, of course, right? So Sentry comes into play, and then suddenly we can see all the things, all the mystery behind the scenes. Talk to me about getting to root cause of an issue with Sentry.
See, what's really nice about Sentry is that it can point you to the exact line of code that went wrong, and all the things around it that led up to that. So the HTTP requests that might have happened, and the status codes that you got back with it, and the data that you got back with it, or the data that you posted. Everything is in that issue view to help you diagnose the issue without having to even go to your code or go to your server logs. Everything is there captured for you. And alongside that, you also have the ability to use session replay, which combines what the user did on the web page, on the phone, on the device as well. So you can marry up the actions that led to it, all of the data behind the scenes, the HTTP requests, and then the line of code and the function and everything else that happened around it. And you can even see, for example, if the error came from like a dependency and not your code itself, because it will show you the exact kind of like dev error you would get in your console if you were running it locally. And that's just so valuable because, you know, especially as a dev working in these larger organizations with 1 billion microservices, you're running Docker locally to get like 1 billion microservices started and connected up to like run a checkout flow, for example, on your local machine. That debugging takes time. And also we know how difficult it is to replicate real user behavior in a development environment as well. And you don't need to do that when you have the insights that Sentry gives you and that points you to the root cause. It just makes like diagnosing bugs like instantaneous almost without having to go through the rigmarole of replicating it live. And it's a dream for people on call. You know, I used to be on call as a dev, you know, in the middle of the night, 2 a.m., I'd get a call, oh, users can't check out. We don't know what's wrong. We had no error monitoring back then. I had no stack traces and session replay and all of that stuff. And I had to replicate it locally and probably fail at that. And, oh, sorry, can't fix it. I need a team on it. We need like more people. We need an incident room. We, you know, remember the days of war rooms? Can you even call them that now? And so with Sentry, you don't need that. Like one person can look through everything, have all of the information they need, and then go fix it.
Okay, get Sentry, go fix it. Too easy. Check them out at sentry.io. That's sentry.io. And make sure you use our code CHANGELOG and you'll get $100 off the team plan, which is super awesome. Again, use the code CHANGELOG, get $100 off the team plan, sentry.io.
Today on the show, we have Jason Hall, a principal engineer at Chainguard. Welcome to the show, Jason.
Hey, good to be here.
So for those people who probably maybe have never heard of Chainguard, which is, I mean, for myself in a container space, that'd be surprising, but give us an overview of what Chainguard is and what you do.
Chainguard produces container images that are hardened and minimal and up to date as much as possible. That includes like sort of development time images like a Go image, a Python, a JDK image, runtime images to run your app on top of. We have a very small static image for Go binaries, but also Java JRE and Python and a bunch of stuff like that. And we build images for sort of application images, like for Cert Manager, for Postgres, for Kafka, for Zookeeper, and a million other things. The value we provide is we keep them up to date to get rid of CVE fixes. We actually try to get fixes like even faster than upstream, and then make them as small as possible so that there's nothing in there that you don't need to get away from even more CVEs. We have a number of public latest images available for everything we build, basically everything we build. And then customers can get an SLA on CVE fixes, every version tag we provide, and FIPS variants for like certain regulated industries, government applications, things like that. So yeah, we try to make hardened minimal container images at scale as quickly and as well as possible.
I have so many questions. What's your release process? Because it's got to be hard to release that many like architectures and like different images, but like how do you release them before upstream? Because like how do you go through all the testing and then know upstream's going to take them?
There's a lot of questions in there, which I'm happy to answer.
I have so many more. I'm holding them back.
Wonderful. Excellent. You mentioned architectures. We only build for ARM and x86 right now.
Only? Come on.
only 99% of the use cases. As for our release schedule, we have a scheduled build every, I think it's 2 hours, but also during the workday, we also just push every change from main. So like as someone is doing fixes to the image, it's also rolling out those config changes. You mentioned testing. There's a ton of interesting stuff about testing. We don't do, I think, enough testing. I don't want to make it sound like that they're untested images, but the testing bar is very high, I think, and we can always improve there. The testing we do on the images as they go out the door is actually part of a really cool thing we do. We build everything with Terraform. We configure all the images with Terraform. And one of the nice things that gives us is Terraform is also usable to spin up and deploy resources, cloud resources, local, kind cluster, K3S clusters locally, and interact with them and deploy Helm charts and things like that. So we will build an image, let's say for Cert Manager, and before we tag it, we'll send it to a Helm release for that image, make sure that it works, run a script against it, do some sort of basic smoke testing on it. And then only after those tests pass will we tag it as latest and release it out into the world.
So are you only patching for CVEs of like the actual container or of like languages, containers, like security bugs, like all of the above?
Yeah, our patching story is another huge, gigantic set of infrastructure. Unlike most image build processes, we separate package builds from image builds. The image builds just take packages and put them into an image. Think like in a Dockerfile, apt install foo-barbaz, things like that. Our image build process can only do that. It can only put packages into an image and set metadata like, users and what paths should exist and things like that. The packages then is the actually interesting part, like how we build these upstream source repos into packages is using a tool called Melange, which takes upstream source, fetches it, runs a build step. And because we are responsible for building those packages ourselves, we can also inject patches into them at that time. So we'll do things like, let's say it's a Go application has a dependency on some vulnerable upstream project of it, then we can actually inject a patch to say, go get, update that dependency to the fixed version before they upstream apply that patch and do their own release. So generally, this is considered safe. I mean, I think Go is really good for that, for minor changes like that. We do have, again, a set of smoke tests that we run before that package is considered okay.
So when you say upstream, are you talking about like, let's say Rust or like OpenJDK or like one of like, I don't know. Are you talking about like languages upstream or like container upstream, or who's your upstream?
The upstream projects, like Rust is one of the packages that we, build and put into a package and then put into an image. But everything also, like I said, Cert Manager and Postgres and Kafka, and we have a Go image and a JRE image, a Python image. All those projects are the upstream. So because we build from source, we're able to also apply a patch or do a dependency upgrade before the upstream open source project is able to update that and then do a release. So we get those CVE fixes out even faster in a lot of cases then.
Are you also part of like CVE reporting process for any projects? Because I know like a lot of the maintainers will get, here's the reports. I'm going to, announce this publicly in 2 weeks. You can have time to fix it and patch things. And then all these mysterious releases happen in the next 2 weeks. But I'm assuming you're still outside of that process, right? Like you're not inside of any of the languages, C and CVEs as they come in.
Yeah, exactly. A number of open source projects, really high profile, broadly used ones, have embargo processes for things like that. We're not a part of any of those embargo processes currently. We'd love to be. But the sort of interesting thing about that is even though we are only working on the public information about these releases, we're usually able to get that release into the package and into an image and into the user's hands before the people that are part of the embargo are able to. So, those embargoes exist because, traditionally the software takes, 2 or 3 weeks to get through their system. So you better get 2 or 3 weeks worth of forewarning. Well, if it takes, 3 hours to get through the system, we can just wait until it's public, take the release, put it in, ship it out the door. That being said, if we were part of any of these embargoes, we would be able to get it, the second it was unembargoed, we'd be able to, publish that image. But yeah, it is always interesting to see usually starts with there will be a security release on Tuesday, no more information. And then you start on Tuesday at noon, you'll see 3 PRs were opened and merged within 5 seconds. And then a release was cut. Interesting.
There's so many directions we could go right now in this conversation. The reason I wanted to initially have you on the show was when you were talking about the container build process, because everyone that is familiar with container builds is here's a bunch of Docker files and we manage Docker files in various ways. And you were telling me that all of your container builds are Terraform based. And that was interesting to me as how are you managing? Why did you pick Terraform and what benefits do you get from removing Docker files? I'm assuming Terraform is still calling Docker or packaging something, but I could be absolutely wrong there.
Our journey to Terraform didn't actually start off as a journey to Terraform. We set out wanting to build, these really hardened, really minimal, really good images. And at first, when we started, we didn't have hundreds of them. We have hundreds today. We had, 5 or 6 JDK, JRE, Python, things like that. We built a tool for this called APKO, APKO. Sometimes it's called APKO. There's no official pronunciation of it. But APKO does not use Docker to build images. Because all it's doing is taking existing packages and putting them in an image. At their very core, these packages are tar files, gzipped tar files, and all an image is gzipped tar files. So you really don't need to invoke a container to move them from one to the other. You can just untar, retar, HTTP push to the registry. So that's what APKO does. And that worked for a while, right? We could build, a very minimal good Python image, a very good minimal Go image. And then we started to get more and more and more of them. And we were at that time releasing on GitHub Actions. We had a big, gigantic sharded GitHub Actions release that would do all of these, invoke the APKO CLI to build each of these. And I don't know how broadly this is known, but GitHub Actions has a shard limit of 256. So once you create a shard matrix of 257, the whole thing just breaks. We found that out, I think, when we were about at 220 images. And so we had not much time to figure out how to get around this. And of course, we had terrible ideas about how we could, shard the shards and, sort of lean into the terrible situation we built for ourselves.
Let's make an org just for this, and then we'll splinter more orgs and more repos. Wait a minute.
Believe me, we had every bad idea it's possible to have. But it was sort of around that time that we kind of looked around and thought, we don't like this. We don't want to double down on this world. Because of some other projects that some of us had been involved in, we had built a Terraform provider for other container build tooling that, sort of on a whim, on a weekend, we throw together a Terraform provider for this. And we really liked it, actually, and we use it to this day. So we had some experience building Terraform providers, and we thought, Terraform's pretty good at declaratively sort of mapping out the change you want to make, and then it can show you that plan, and then it can apply it. And that apply is entirely orchestrated by Terraform. You just say, I want, traditionally you say, I want, 500 VMs and 6 Kubernetes clusters and 2 load balancers and whatever. Terraform, make it go, and it does it. Well, if we write a provider for APKO, it's not terribly hard to say, build 500 images with these packages, show me the plan, and go. So that's what we did. We built the Terraform provider and freed ourselves from the shard limit of GitHub Actions. We have since had to reshard because we're building too many things on those poor runners. But we're at least out of the business of having to fight GitHub's 256 matrix shard limit.
You said you build 2 architectures. Are you building all the latest versions of each language and different architectures and like JDK, Rust, like Python? Are you building all of the like available versions of each?
We mainly only build what is supported upstream. So something like Rust is only, I think Rust only has one latest, don't quote me on this, only supports officially the latest version. Go supports the last 2. Python supports the last 3, I think maybe 4. So we build currently each of those supported versions upstream. And then as the old versions sort of fall off the tail, we pick up the new one and drop the old one. But yeah, we build every supported version for both architectures. Currently there's 2. That's the sort of set of packages we have. And then the image build infrastructure puts together all the packages for all the architectures we support, pushes them off to the registry.
That's amazing. It's really hard to build different versions and different packages. And I don't think people realize how hard it is to build different architectures and to keep it all going and test passing.
Yeah.
Especially as quickly as they're coming out with that many images, right? Because like I could do it with 1 or 2 and I'm like, oh, now I want to do 10. Okay, well, what other decisions do I have to make? Did you find anything surprising with your move to a Terraform provider? Because like Docker is known for having this DAG that they create, like the directed acyclic graph is like, hey, that's what Docker does, but also that's what Terraform does. And they just do them for different resources. Do you care about any of that? Or is it because you're doing something a little more simplistic of untar source, do a little bit tar source, and not going through like a multi-stage build process? Were there any surprises that you found when moving to Terraform?
Hundreds of surprises. So you're totally right. Docker builds execute a directed acyclic graph of steps. If you have, multi-stage builds, many parts of those can run in parallel and then only sort of join at the end. This all goes back to the sort of philosophical change we made right up front to say package builds are different than image builds. Package builds build source into like a contained, think of like a deb. We use APK from the Alpine ecosystem, but think like a deb or RPM or something like that. They're all just different sort of formats of tar. But source to an APK is one step. And then taking those packages and putting the right packages into an image and pushing it to the registry is the other side. By splitting that, we get a lot of benefits, right? The second step can be really dumb and really fast because it's only doing tar and HTTP. We've since made it more complicated, but at its core, it's basically just doing, tar, make an image, push it. And the package side is relatively linear, right? Like there's not a lot you can do to parallelize it or to make it into a DAG that you can execute concurrently. It's mainly fetch the source.
Write files to disk, read files to disk, write files to disk, right? It's just
yeah. That's perhaps an oversimplification, but
sure.
For the most part, there's not a lot you can do besides just throw more resources at this linear build. That's not the case with a bunch of image builds, which are just fetching tars, doing stuff, and pushing those tar files back up to the registry. That's very parallelizable. That's if you aren't pulling and pushing as fast as you can, you're doing it wrong. You should be able to do that as fast as you can. So that's where Terraform really helps with its DAG, is we're not building sort of a bunch of Docker builds concurrently, which each execute their own DAG. We're executing a bunch of APKO builds concurrently, which are unrelated from each other and can really be super parallelizable. You asked about other surprises along the way. And I should mention, the testing story of these images is also complicates things, right? So we build an image, we push it to the registry by digest. It's not discoverable. No one should be able to use it yet. Then we run tests on it. We put it in a real cluster. We run some smoke tests on it. Can I create this resource? Can I, send a SQL query to Postgres? Can I make a Java build? And only after that passes do we tag it as latest or with whatever version. What gets complicated is if you're doing this massively parallel image build, you're potentially spamming one cluster with just a ton of the entire cloud native ecosystem landscape installed on one little kind cluster locally, and that thing grinds to a halt. So a lot of the work we're doing lately has been to isolate these tests from each other, spin up a K3S cluster, install Cert Manager on it, run a test. When it passes, tear down the cluster. Spin up another one with, Crossplane, spin up another one with Calico, spin up another one with whatever. So they each get their own little tenant and don't have to, first of all, vie for resources, but also there's a lot of webhook validation that breaks something else being installed. 2 copies of Cert Manager don't like to be installed at the same time. So that was a big surprise for us when we started running stuff as parallelly as possible. A lot of things don't like to run in parallel. when it comes to testing.
When Helm version 2 came out, I once ran a for loop on every Helm package that was available and installed it in my Kubernetes cluster just to see what would happen. And yeah, there's so many things that are like, no, like this, we can't install with that other thing.
I love that you did that on purpose.
Yeah, totally. It was fun.
Did you have a fan for all the smoke coming out of it?
I know. Like you're poor. Like,
it was in GKE. It wasn't my fan.
It's in some data center.
Yeah.
like we're breaking somebody's stuff. He's like, it's not mine though, so it's cool.
Yeah, I wanted to see where it breaks. And that's the interesting, like you were just pointing out, like when you put all of this stuff together, you find where the boundaries are for how they're supposed to work. And you're like, actually, these two things should never be installed together. And now we have to put logic somewhere, either at the early in the packaging pipeline where we have other logic, or later in the testing to say like, oh, now it's going to take longer, so we have to make 18 different clusters to verify these things. And yeah, like you have to just shift where that logic is based on those boundaries of other pieces of software.
Yeah.
Sometimes that's honestly the only way you're going to find out is when you do it.
Exactly. It's I don't think we would have done this if we knew it was this hard, but I'm glad we're doing it this way because what's that saying? We don't do it because it's easy. We do it because we thought it would be easy.
Yeah. I think, isn't that like software in general though? Like it's always like, this is going to be so easy. It's going to be like 3 lines. And then like 6 hours later, you're like reassessing your life decisions.
If you weren't naive going into it, like you would have not gone into it, right? This is just like, hey, I got this. This is like that. Simplify everything down to like the pieces you know, and then you're just like, oh, actually, this is really hard. And I see why no one's done it before.
Yeah.
The Terraform module that you wrote, because you have this aptco binary, which basically is doing like, at the end of the day, a Terraform module executes some code. Is the Terraform module under all the covers a shell script that executes aptco to do the thing?
No. So Terraform providers are written in Go. Luckily, we're a pretty Go-centric place. AppCo is written in Go, and Terraform providers are written in Go. So we basically refactored the important bits out of the CLI into libraries that we could call from Terraform. That being said, there's also, among the Terraform providers we have, is one that runs shell scripts. Like all it does is take an image and say like, can I run whatever Docker run -version on this image? So we do, at the end of the day, run a bunch of shell scripts, but for the most part, building the image, or completely for building the image, and most of the time for standing up a Helm release, we use the Helm provider for that.
Is that why you picked Terraform, because you're a Go shop, or what was your why Terraform compared to its competitors?
Yeah, that's a good question. We have in our past a lot of Bazel experience, for better or worse. We generally, I like what Bazel's doing. I think it's a good idea.
What is Bazel? I don't think I've ever used that before.
Bazel is a distributed build tool from sort of forked out of an internal tool at Google called Blaze. But Bazel is very much, DAG based. You create modules and they link to each other and depend on each other. And then it says, okay, I have this graph of stuff to do. I will do it as fast as I can, as concurrently as possible. We have some experience with Bazel, with writing Bazel rules, with things like that. Bazel is kind of, the extension model is run this script most of the time. It's like, the plugin model is tell me what bash script to run. And so we didn't, for a lot of reasons, end up going with Bazel. Terraform seemed really good. We were also using Terraform to stand up all of our infrastructure, like you traditionally do with Terraform. So we had a bit of experience with it. And really, a really nice thing that came out of it is being able to use the Terraform infrastructure release code and providers with the image build provider. So you can build an image, run a test, and then tag it end to end without having to sort of context switch from, am I in build mode? Am I in test mode? Am I in whatever mode? To Terraform, it's just executing stuff, and it might be anything.
I feel like releases are hard, so anything you can do to simplify them and stop having, not stop having, but to prevent as much human error or manual intervention, the safer your release usually is.
Yeah, and Terraform is really, it's built for making releases in general, like infrastructure releases, as safe and observable as possible. So it really was a good fit for also tying into our image builds.
Yeah, and the more information you can collapse into a single DAG, the better, right? Because the more you put in Terraform, the more it knows about other steps and the better decisions it can make about the ordering of those steps. And once you get to a bash script or a Jenkins file that calls a make command that executes a bash script, you're just like, oh, now I need to figure out how to get this back into the Jenkins file. And you're just like, this is a bad idea.
Yeah. If you're only going through 3 different languages to do that, you're doing it right. It's really a Jenkins file to a make file to a bash script to a make file to a bash script.
Yeah, the circular. Yep, for sure.
Know that life. So when you say hardening, what do you do to harden your images that other processes don't have? Like what? And then how did you? When you tell us what you do to harden it, how did you come up with the process to harden these images?
Hardening means a couple of things. I think the main thing we do is make them as minimal as possible. Most images out there, like the Docker Hub Python image, is based on Debian, which is a very stable, solid base to work on. But because it takes the Debian base image and then puts Python in it and says, here's your image, it includes all of Debian. It includes all of, everything that comes in a standard Debian install and everything that's needed to install Python. It's a lot bigger than it needs to be just to run, Python, hey, run this script. So a lot of the hardening we do is just cutting out that stuff. This is another place where building images from discrete packages only is a really beneficial thing, because all of the stuff it took to build Python doesn't matter. We just take the Python that was built and put it in an image. It's sort of like multi-stage builds on steroids. What it takes to build a Java application is not what you need to run it. So we hide all the stuff that it takes to build JDK or JRE. We put that in the package build process. And what comes out of it is just the bare minimum needed to run these applications.
The video game nerd in me is like, this is like containers with cheat codes.
Yeah. Well, we had to sort of go back to square one and really think what are we trying to do here? What is it at the end of the day that we're trying to build? It's tar file systems to build stuff on top of. Okay. We don't need to run inside of a Dockerfile. You can actually just build tar files and put them in the right format and push them. And that's an image.
That's a cool part of hearing people's motivation for things, because it's amazing how innovation comes out of needing to do something or needing to make something smaller or bigger or better. And then you're like, wait, this solves other problems that I didn't know we were going to solve in the process,
Yeah. A lot of it, especially early on, before we ever started Chainguard, was a lot of us worked on the teams that built these images. And so we had to wrangle Docker files daily and understand changes to them. And, Docker files are great, and the ecosystem wouldn't exist if they didn't come around. But there's a lot of complexity to them if you let there be.
I've said a lot of bad words at Docker before.
Nothing I'm allowed to say while recorded, unfortunately.
Yeah, no.
During your minification process, did that change expectations from users of the images downstream? Because the more I got used to Python including Debian in it, the more I just kind of abused that and said oh, actually I can just call this bash script because I know it's going to be there. And literally today, it's my second week at my new job, and I just submitted a PR to remove 5 bash scripts that weren't being used. I was like, there's no bash on the system. We should just take those out. Are you actively pulling things out of the system to say hey, you don't need this? And then a user downstream is going to be like, actually, I was using that. Please put it back.
There's an XKCD comic about oh, I removed this hop for loop in the middle of the thing or whatever. And someone files an issue that was that's how I warmed my tea. I ran this script and then I put, I put my tea on the keyboard and that's how it heated up. Why did you remove that feature? Absolutely. Right. Exactly like you're saying, people don't know what it is in the base image that they depend on, really. It's at a certain, organizational level, it's impossible to tell what it is in that image you actually need versus what happens to be. Things just work because bash happens to be in that image. One solution to that is we have a dev variant of basically every image we produce. So there's a Python image that does not include bash, and then there's a Python image that does include bash and the APK tool to install more packages if you need to. So you can use that dev image as a base image in your Dockerfile and APK add any other thing you need, and then that's your new base, and you can go from there. In general, that I don't recommend that in general, because you're sort of not fixing the problem, you're just fixing the symptom.
Yeah.
If your Python script has a load-bearing bash dependency, reassess why that is. Is this really something necessary? A lot of times it's something you find out when you get it down to it that it's something stupid, like it needs to shell out to date to get the current date. I'm well, just don't. You don't actually need bash. You can Python is perfectly capable of telling you what date it is.
Yeah, there's a whole library for that.
Yeah, and I don't think it works by shelling out to bash.
I don't know. Sometimes
as I said it, I was like, oh, I really hope it doesn't.
I've been struggling, writing the struggle bus with Python the last couple of days, and I'm pretty sure you can do it just with regular Python.
Yeah,
so I think you're right.
Yeah, a lot of it is, and we do get reports from users and customers about why doesn't the Python image include some tool that I needed, and a lot of it is either we provide the dev image as an escape hatch for you, but also just education about like go look in and see why you actually need that. Oh, you don't actually need it? Great, we're all better off. Like you improved your software to be more reliable and more dependency free.
It's amazing what can go wrong, like with the dependencies. Like I was writing an automation script the other day, and like my senior engineer was like, take as many dependencies out, and then you like start looking at what you can do and what can go wrong having more dependencies, and it really changes the way you think when you're doing the design.
Yeah, and it has a huge impact on the number of vulnerabilities that scanners pick up in your image, right? Like if your Debian base image has 50 tools in it and Python, but you only need Python, then you're going to pick up CVE scanners are going to pick up issues in all of those other things, right? It's the same. You don't actually need it, and there is a cost of having it. There's a cost to your scanner results and your accounting for those things.
Yeah, and it just puts your software at more risk too. So,
yeah.
The last question I really had was around why APK? Like I've written spec files for RPMs and deb packages. I've never written one for Alpine for APKs. Like, why did you decide to choose that as your ultimate packaging format before you build those containers?
That's a good question. I think mainly it was we had some folks on the team that were very involved in Alpine and knew that format. And that's kind of just what we ended up with because that was the first thing we tried. It seems to work out so far, so I don't think we're in any rush to move it. The Alpine community has a lot of the same sort of ideals as we do. They try to be as minimal as possible. They try not to, make it easy to accidentally depend on too much. And I think the APK format is good for making really small packages that have dependencies on each other. I don't know enough personally to say that debs or RPMs or anything else have better or worse. I don't know the differences. But yeah, I would say basically we chose APK because we had some familiarity with it, and then we've gone from there.
And that makes, like debs and RPMs were created at a different time when things were a little more complex, that all the complexity was put in the package manager to build not only the dependencies, but also like mocking systems for how are we building this in a clean environment, right? Like you had VMs and clean directories and whatnot to say like, hey, we need to build this. And I feel like, again, I've never written at APK before, but I feel like that is much more of a container centric, like, hey, we already have this thing that exists that envelops a thing and we can untar it and tar it, and the container is the eventual place to run it. I don't know uses for Alpine much beyond container environments.
Yeah. As an example of that, Alpine has, or APKs have the ability to run scripts when they're installed, right? A lot of package managers do. Like when you install, apt install foo can actually run another script and do something else. Because it needs to set up a user, it needs to set up a directory, it needs to all kinds of those things. APK has that ability too, but APKO doesn't use it. So if the APK describes some script to run after startup, the image we build with that APK won't run that script. There's no run, in the APK layer. There's no arbitrary script execution. So that encourages us to put everything we need, encode it in the APK's file system instead of in who knows what in the trigger that runs after that package is installed. That's absolutely an artifact of that we are building for the container ecosystem of 2024 and not the, mainframe ecosystem of 1985. Computers have changed a lot. We have we prefer immutable infrastructure. We prefer, nobody's like, execing into Docker containers and doing upgrades on these packages. We just nuke the whole thing and restart it, possibly on a new node. Well,
are you sure?
hopefully not. We would prefer them not.
That's very aspirational of you, and
no
I
one's
applaud
doing
your
that,
efforts.
Tomorrow someone does it.
I don't want to go into it because we don't have time, but that's the whole, like, there were definitely systems that encouraged that behavior that said, you have a container, you run it out there, we create a new init system for you, and we will upgrade this on demand and you never have to restart it. I'm like, actually, no, like that's just a weird uptime thing that we wanted to have on hardware, and we don't want that anymore.
It's amazing how technology goes in these cycles, and then they're like, everyone should do this. And then we're like, never mind, don't do it. Horrible idea, our bad.
That's just experience. People try something, find out it's terrible, try something else, find out that's terrible.
And being naive about why it's terrible, right? Like that's how you get good and bad from it.
I think that's the science of computer science. So you have to try things, break it, do some stuff, and then you're like, oh, that was a horrible idea. Let's never do that again.
Yeah, as long as you're learning. It's okay to break things as long as you're learning along the way.
Yeah.
Jason, this has been great. Thank you so much for coming on and talking to us about how you're building containers with Chainguard. Where can people reach out to you or find more about the container images, look at some of these Terraform files that you're building, or just ask you other questions?
My Twitter handle is I'm Jason H. You can tweet at me or DM me or anything.
I'm as part of that.
I'm is part of that. Yes. The letter I, the letter M. This is terrible.
I'm. Yes, I got it.
I picked this username when I was 16 and I didn't know I was going to have to say it over podcasts and over customer support.
Okay, but can we talk? I'm so ashamed of the usernames I picked in high school.
Oh yeah, this is the best one I had.
I know.
Let's be honest.
I was gonna say that's not even bad. Like some of them, I'm like, oh my god, let nobody ever find this.
We won't go into that. You can also you can go to chainguard.dev to learn more about everything we offer. There are all these Terraform repos are fully open source. The GitHub org is Chainguard images, Chainguard-images. And yeah, come take a look. Let us know what you find.
Awesome. Thanks so much.
What's up, friends? This episode is brought to you by our friends at Synadia. Synadia is helping teams take NAS to the next level via a global, multi-cloud, multi-geo, and extensible service fully managed by Synadia. They take care of all the infrastructure, management, monitoring, and maintenance for you so you can focus on building exceptional distributed applications. And I'm here with VP of Product and Engineering, Byron Ruth. So Byron, in the Nats versus Kafka conversation, I hear a couple different things. One, I hear out there, I hate Kafka with a passion. That's quoted, by the way, on Hacker News. I hear Kafka is dead, long live Kafka. And then I hear Kafka is the default, but I hate it. So what's the deal with Nats versus Kafka?
Yeah, so Kafka is an interesting one. I've personally followed Kafka for quite some time, ever since the LinkedIn days. And I think what they've done in terms of transitioning the landscape to event streaming has been wonderful. I think they definitely were the sort of first to market for persistent data streaming. However, over time, as people have adopted it, they were the first to market. They provided a solution, but you don't know what you don't know in terms of you need this solution, you need this capability, but inevitably there's also all this operational pain and overhead that people have come to associate with Kafka deployments. Based on our experience and what users and customers have come to us with, they would say we are spending a ton of money on a team to maintain our Kafka clusters or, managed services or something like that. The paradigm of how they model topics and how you partition topics and how you scale them is not really in line with what they fundamentally want to do. And that's where Nats can provide, as we refer to it, subject-based addressing, which has a much more granular way of addressing messages, sending messages, subscribing to messages and things like that, which is very different from what Kafka does. And the second that we introduced persistence with our Jetstream subsystem, as we refer to it, a handful of years ago, we literally had a flood of people saying, can I replace my Kafka deployments with this Nats Jetstream alternative? And we've been getting constant inbounds, constant customers asking, hey, can you enlighten us with what Nats can do? And oh, by the way, here's all these other dependencies like Redis and other things and some of our services-based things that we could potentially migrate and evolve over time by adopting Nats as a technology, as a core technology to people's systems and platforms. So this has been largely organic. We never, from day one, with our persistence layer Jetstream, the intention was never to say, we're going to go after Kafka. But because of how we layered the persistence on top of this really nice pub sub core Nats foundation, and then we promoted it and we say, hey, now we have the same semantics, same paradigm with these new primitives that introduce persistence in terms of streams and consumers. The floodgate just opened and everyone was frankly coming to us and wanting to simplify their architecture, reduce costs, operational costs, get all of these other advantages that Nats has to offer that Kafka does not whatsoever, or any of the other similar offerings out there. And you get all these other advantages that Nats has to offer.
So there's someone out there listening to this right now. They're the Kafka cluster admin, the person in charge of this cluster going down or not. They manage the team, they feel the pain, all the things. Give a prescription. What should they do?
What we always recommend is that you can go to the NATS website, download the server, look at the client and model a stream. There's some guides on doing that. We also have Synadia provided basically a packet of resources to inform people, because we get, again, so many inbound requests about how do you compare NATS and Kafka? And we're like, let's actually just put a thing together that can inform people how to compare and contrast them. So we have a link on the website that we can share, and you can basically go get those set of resources. This includes a very lengthy white paper from an outside consultant that did performance benchmarks and stuff like that, and discuss basically the different trade-offs that are made. And they also do a total cost of ownership assessment between people who are organizations running Kafka versus running NATS for comparable workloads.
Well, there you go. You have a prescription. Check for a link in the show notes to those resources. Yesterday's tech is not cutting it. NATS, powered by the global multi-cloud, multi-geo, and extensible service that is fully managed by Synadia. It's the way of the future. Learn more at synadia.com/changelog. That's synadia.com/changelog.
Thank you so much, Jason, for being on the show and telling us all about Terraform and building containers. And I always try to find out where in the stack is the bash, because every stack has it somewhere at some level. And I feel like there's a makefile or there's bash. And it's very interesting to hear how they were building that out and some lessons they learned with doing that at scale in an open source way with all of these different architectures and applications, just to be able to build those containers. That sounds so cool. Cause starting with Dockerfiles does sound like a nightmare. Once you get to 10 or 50 applications and containers you have to push out regularly. So to close out the show, Autumn, let's talk about a couple links we found. We'll probably put this at the beginning of the show, but because this is our first one, we still wanted to bring up some things that we read recently that we found interesting or learned this week. So why don't you go first?
So my link is how satellite images and AI could help fight spinal apartheid in South Africa. So it is by the people at DARE, I think it's called, Distributed AI Research Institute, and it's by Timnit Gruber. She is the AI PhD who left Google because they didn't agree with her ethics paper and they kind of tried to push her out. So she is using data to help people to get more democratized resources like school, healthcare, parks, and hospitals, and able to get more resources after apartheid had really separated a lot of those resources, and the resources have stayed separated and out of the reach of a lot of people that really need it. And they're going to use data and imaging and AI to basically redistribute those and to make a case backed up by data to help make things better for those people that don't have access to those things. But it's really interesting the way that she did it. It's in the MIT Tech Review, which is one of my favorite sources for articles. And it's just really awesome. People talk about bad things AI will do and then how AI will be profitable. But this is really cool to see AI being used to help people and to, I guess you could say, kind of right wrongs that were done in history, and it's going to be used to make things better for people and at no cost to people. So it's really cool.
And essentially, if I understand it, they have satellite imagery. They're looking at the land and then seeing places that are basically, this is green, or there's more buildings, or there's more roads and whatnot. And you can figure out from that, where's the funding going? If you look at enough land and find those patterns, right?
Sort of that, and kind of how far are schools? For instance, I forget what state it was. I think it was Detroit, but they did a study showing that because they had done charter schools, the schools were more and more out of reach of people who had less socioeconomical power, so the schools just got further and further. Kids were catching multiple city buses. So this is kind of the same thing. Are schools super far away? Do they have access to healthcare? How far is it to get to those healthcare? Are there any parks in that neighborhood? How far are they from hospitals? What does it look like from above? And it's just amazing how this is one of the examples of how AI is going to help things like this, things like medical treatment and all these different ways that you may not initially think of when you think of artificial intelligence, but it's going to improve people's lives.
That's cool. My link for this week is called, it's not microservices or monolith, it's cognitive load you need to understand first. And it's by Fernando Villalba, I believe is how you'd say it. It's actually from December, but I recently read it. And it was a great read, mainly around this argument of should I build a monolith or microservices. And one of the things that I remember as a platform engineer was we always said that we reduce cognitive load for the developers by not having to think about all of the things. We just kind of made sane defaults for them. And in the argument here in this article is very much similar, where it's like, how much are you dealing with like the just thought process of a release cycle or debugging things or how things fit together and like network latencies, like really understanding how much cognitive load your team can handle is what determines your architecture for what you should be building. Because if you try to make it too many small services, that increases your cognitive load to say, oh, even if it's a single piece of functionality, how that thing talks to something else is much more difficult when it's over a network or through a load balancer than it is if it's a library that you import and you it just makes a call to the same application in a thread. And so I really enjoyed the article just taking that sort of argument and flipping it on its head of like, well, like let's look at what your organization or your team is capable of maintaining in their heads and being able to debug before we even talk about like, oh, should this be a separate repo or not? Or how do I deploy this thing? So I really enjoyed it. It's just one of those things that there's arguments all the time because one company does a microservices doesn't mean you should by default. You really need to look at your team and what your team is capable of and how much cognitive load that's going to put on everyone in the team and the organization.
I think that's a really interesting article because it's not a way that I don't think people think of when they're building projects or when they're building maybe engineering teams or just how they want to try to shape their goals, for the year and all of that. So I think it would be really interesting to see like the return on investment of like thinking that way, like I wonder if people would be innovating faster or innovate more because of the like reduced cognitive load. And it would be really interesting to see like if they could not only implement that, but then take metrics and see like if they were more productive or not, because it just seems like if you're lowering the cognitive load, you could be more productive and do more with your time.
Well, and one thing they point out in the article is not all cognitive load is bad. Like the goal isn't to reduce it as much as possible because there's a cognitive load that helps you do what you do best. Like if you are an expert in a certain programming language, there is an amount of cognitive load that you have, but you want to keep that. You want that around to be able to dive deeper into that particular area of whatever it is your specialty is. And so I thought that was really neat because it's not all about like, how do we make it so you don't think? It's like, that's not actually the goal here. Like, let's like help you think about the things that are important and you add value to the organization or the business or whatever by like being able to have more cognitive load in the areas where you should have that cognitive load.
It would also be interesting to see what the cognitive load is and things that you enjoy doing and that you find interesting. Because like there's already so many studies about how people innovate more when they're interested or something that they enjoy doing. And I wonder what the difference would be there.
Yeah, I'm sure that a lot of that just goes into like how easy it is to retain some of that information too, right? Because it doesn't feel like cognitive load because I'm very bad with names and faces. So it's a lot of cognitive load for me to remember someone's face, even if I'm interested. Like I'm really trying, but I really, really have to think about it over and over again to be able to see like the next day, oh, I remember who you are now. And that is a hard thing for me to do. But for some weird reason, my entire life, like I can remember like horsepower for cars because I liked cars. And I was just like, oh, I remember that car has 320 horsepower. Like, I don't know why. Like, I can't tell you the person's name that I met last week, but I can tell you what they drive. And I can tell you how fast it is. Like, it's just a different sort of like what you can latch onto and what's interesting to remember.
I think it's just a different feelings when you do something that you're very, very interested in, especially I think because of the way that like engineering people that work in tech just generally seem to work, like there's how many jobs, that people build a bunch of projects on their own or like they were found for that job because of projects they contributed to, like so much of it is different than most jobs and the motivation and how people seem to really generally enjoy that job or work on projects in their own time or just be like some sort of an interest, I wonder what the relationship would be between those.
Well, thank you everyone for listening to the show today. We want to hear from you. If you run software in production, let us know. You can reach out to us on email. shipit@changelog.com is probably the best way to get a hold of us. We have some great guests lined up that we already are excited to talk to them about various things. And there is a lot of variety in the types of software and infrastructure. I know we have someone coming to talk about space. We have people talking about social networks. We have people talking about all different stacks. And so if you are running production software and you'd like to be on the show, please send us an email and we can figure out a schedule and some topics that we'd be interested in learning from you from. So yeah, definitely drop us an email.
I'm really excited about the space one.
Yeah, space is going to be great. But again, yeah, thanks everyone for continuing to subscribe. And if you have friends that you want to show to, obviously send it to them, because we are going to be continuing this show for a week, or every week now for the foreseeable future. And we want to help people just get into running infrastructure and understanding kind of the challenges and what it's like to be a production engineer, developer, anyone in this space. So thanks, Autumn, for coming, and we'll talk to you all soon.
Thanks.
Thank you for listening to Ship It. We're back, baby, and we have a lot more in store. The plan for now is to ship this show out on Fridays. Yes, we do push to prod on Fridays around here. What could possibly go wrong? Thanks again to our partners at Fly.io, to our friends at Sentry. Don't forget to use code CHANGELOG to save $100. To Breakmaster Cylinder for beat freaking for us, and to you for listening. We appreciate it. Oh, one more thing. We do have a membership program. It's called Changelog Plus, and you can join to directly support our work, make the ads disappear from all of our pods, and get bonus content. For example, our interview with Jason Hall went an additional 5 minutes, which Plus members will enjoy right after this outro. Get in on the goodness at changelog.com/plus.
Changelog Plus. It's better.
On the next episode, Justin and Autumn speak with Andrew Gunther all about shipping code in space. What do you do when your infra runs 1,000 miles away and you only have access every 90 minutes? Stay tuned to find out.